Hi everyone, welcome to my channel. Today we explore Egypt's mega project carving a new river through desert.
An enormous army of heavy excavators cuts through the barren wasteland to create a massive inland waterway.
Over 100 million Egyptians live crammed inside a narrow 4% strip along the historic Nile Valley. Rapid urban expansion buries thousands of square meters of vital farmland under concrete every single passing hour. To secure food independence, planners turned to Lake Nasser, holding 168 billion cubic meters. Engineers mapped an ambitious 310-kilometer canal route, slicing directly into the heart of the Sahara. The Toshka mega project officially commenced, with the goal of creating Egypt's revolutionary second life-giving Nile. Surveyors manually drove thousands of wooden alignment stakes across hundreds of kilometers of scorching, unmapped desert. Heavy industrial machinery and supply convoys rolled across the desert, creating giant dust storms on arrival.
Engineers began constructing the world's largest pumping station inside Lake Nasser. This was on an isolated aquatic foundation.
A massive circular steel cofferdam was driven into the lake bed, and powerful pumps drained the water. Workers blasted a 50-meter deep canyon through solid limestone to create the deepest inland water intake channel. Heavy rotary rigs drilled massive foundation caissons, 15 meters deep into sandstone, under 50-degree desert heat. A 50-meter-tall concrete fortress rose from the lake bed to withstand billions of cubic meters of water. 24 giant vertical pump shafts, each 3 meters wide and 30 meters deep, were bored through. Inspectors lowered handheld searchlights into 30-meter-deep vertical shafts to verify structural steel integrity before installation. Custom 35-ton industrial water pumps, manufactured in Japan, arrived at the station. Riggers guided 35-ton pump motors down millimeter-precise shafts at a cautious rate of 1 meter per minute. A dedicated 250-kilometer power grid delivered nearly 300 megawatts of electricity straight from Aswan Dam.
Deep underground, 24 colossal steel pumps were aligned like dormant jet engines, waiting for electrical power.
The main station hall was enclosed with panoramic glass walls, overlooking the lake, covering the subterranean pumps. Crews pulled the steel cofferdam, allowing the lake to rush in and turn the station into an island. In March 2005, the first pump fired, blasting Nile water 50 meters upward through solid bedrock. Veteran engineers broke down in tears as fresh Nile water touched the Sahara sand for the first time. Simultaneously, over 2,000 heavy machines cut a 54-meter-wide canal stretching endlessly across the desert. Giant mining dump trucks the size of two-story houses hauled millions of tons of desert overburden away. The project assembled the largest excavation fleet in Egyptian history, operating continuously 24 hours a day.
Loose sand walls constantly slumped overnight, burying the previous day's excavation work under fresh avalanches.
A massive 9-kilometer granite mountain range stood squarely in the canal's path, blocking all forward progress.
The resulting blast was the largest in its history, sending shockwaves felt 20 kilometers away.
Heavy excavators took 9 months to clear 1 million cubic meters of blasted granite from the canal corridor. 70-degree ground temperatures caused hydraulic fluid to boil and split heavy equipment rubber seals continuously. Crews shifted primary excavation work to the night, operating under massive floodlight towers to escape lethal daytime heat. Sudden Haboob dust storms, towering 300 meters high, slammed into the site at 80 kilometers per hour. After storms cleared, workers used GPS to locate buried canal lines. They dug out submerged machinery by hand. A self-sufficient modular camp housed 10,000 workers, 400 kilometers away from the nearest Egyptian city. 80 million cubic meters of excavated soil were compacted to construct wide, heavy-duty service highways along the canal. While digging, excavators accidentally breached ancient underground aquifers, flooding the canal cut with salty water. The underground water was dangerously saline. If mixed with fresh Nile water, it would poison all future crops. Engineers constructed 25-meter-deep bentonite slurry cutoff walls to permanently seal off the salty groundwater aquifers. Mobile concrete batching plants were built every 15 kilometers to supply the endless Gillis Canal paving operations continuously. Massive automated slip-form paving machines poured smooth concrete lining. It moved at a continuous speed of 2 meters per minute. Without immediate protection, extreme 50-degree sun heat would flash boil moisture and ruin the fresh concrete lining within hours. Inspectors enforced zero-tolerance standards, using hydraulic breakers to destroy and replace any cracked concrete panel immediately. Mark that panel for immediate replacement.
The main canal split into 4 major arteries, adding 88 kilometers of concrete waterways into virgin desert.
310 kilometers of pristine concrete canal stood completed, dry and ready to receive river water. Mobile cranes erected massive 400-meter-long center pivot irrigation arms across circular fields prepared in the sand. Crews buried 320 kilometers of wide-diameter steel water pipelines to interconnect secondary desert fields. Certified welders joined heavy steel pipe sections under portable sun shelters to build the desert's circulatory network. Each center pivot arm spans 400 meters, equipped with 40 precision sprinkler nozzles to water 50 hectares. 3 booster pumping stations installed every 60 kilometers maintain steady hydraulic water pressure across the vast system. During initial tests, heavy steel irrigation pivot wheels sank 400 millimeters into wet clay mud, jamming machines. Engineers doubled the wheel width, doubling ground contact area, and allowing pivot arms to roll across mud effortlessly. 400 kilometers of paved asphalt highways were constructed across the desert before any water was even released. Standing at the project frontier, one could look 400 kilometers in any direction and see only sand.
Bulldozers mix thousands of tons of rich black organic compost into dead sand to create fertile farm soil.
Heavy D10 bulldozers with single-shank rippers tore through deep hardpan clay. This allowed healthy crop root drainage. Small test plots powered by diesel pumps were planted to determine which crop varieties could survive desert conditions. The trial harvest produced golden wheat directly from sand, confirming that the impossible mega project could succeed. With canals, fields, and pivots fully constructed, engineers prepared for the historic final master switch activation. A high-voltage master switch was thrown, sending electric power to all 18 active pumping turbines simultaneously. Lake Nasser water surged into the intake channel, wetting the white limestone walls for the first time. A deafening wall of churning white water blasted from the station tunnels, generating its own localized windstorm. Moving at 1.5 meters per second, the water raced forward across concrete that had never been wet. Massive steel sluice gates opened slowly, controlling the immense river volume and bending the water to human will. Vibrant blue water flowed through the four-way desert junction, visible clearly from high above in aircraft. 130 kilometers away, Nile water reached Pivot 1, and the first sprinkler nozzles burst open. Water droplets struck the parched desert crust for the first time, darkening the sand and transforming the landscape. 18 giant pivot circles rotated in unison, wetting hundreds of hectares of newly engineered agricultural land. A fleet of modern grain drills planted wheat seeds into soil that had been barren desert just months earlier.
10 days after planting, millions of vibrant green wheat shoots emerged from the Sahara sand, growing rapidly.
Within 3 months, white egrets, bees, and desert foxes migrated to the new river without being invited. Waist-high green wheat fields stretched across circular plots, creating a lush oasis just meters from dead sand. The harvest yielded 5.2 tons per hectare, matching the fertility benchmarks of the historic Nile Valley. Hundreds of thousands of tons of high-grade wheat were harvested directly from land that once produced nothing. Fields of world-famous Egyptian cotton, sugar beets, and 50,000 date palms now line the desert waterways. A planned city for 2 million residents rises beside the canal, connected by modern 4-lane desert highways. Satellite images confirm dozens of green agricultural circles expanding across the Sahara, transforming the desert forever. Egypt's second Nile stands as a monumental triumph of engineering, proving that human determination can conquer the desert.